Hello, everybody. Welcome back. Today we are going to be talking about transformations of our sinusoidal functions. Before we do any transformations, though, we're going to talk about the most basic sine and cosine functions. So I'm going to draw those before we actually draw all the different transformations of them. There's also some graphing transformations homework, so I will leave you with some to try on your own as well here. A couple extra pages just to try on your own. Okay, but back to the main point here. Let's first talk about how to graph sine and cosine. Okay, so here's our sine function. This is going to be y equals sine x. Okay, and this is going to be 90, 180, 270, and 360. Keep in mind 360 degrees is the period length in this situation. Okay, so here we're going to start at 0, 0, then we're going to go up here, then back down, then down to -1, and then here. So this is one cycle of this graph, and I'm just going to put arrows at the end to show this continues to go, right? This continues after, above and beyond. We can do the same thing with cosine. Y equals cosine of x. And one thing I want to point out about cosine is the same as sine, except it's just shifted over by one, right? I could draw, a new x-axis here and say, oh, well, this is cosine. It's this one, right? I'll actually draw it separately more properly than that, but that's the basic idea. And that's something I did not realize for, well, far too long. Unfortunately, I didn't understand that cosine and sine were really just the same graph, just one was shifted over from the other one. Good. So here we have the exact same points as before, but shifted. And this is 90, 180, 270, 360. Very good. And it continues on forever and ever. So there we have it. So those are the basic trig functions, and we're going to be able to do different things to transform the functions. Before we do that, I'm going to label certain parts of the graph that are important that were not discussed last time. So as we know, one full cycle is the period length. So in this case, the period length is 360 degrees. And that is the default, by the way. The default is that the period length is 360 degrees. However, that said, sometimes if we transform it, it does change. And we'll talk about that when we talk about the transformations. The other thing is called the amplitude. Which is this distance here. And that's the distance from the midline to the minimum or maximum point. Now, by default, this is going to be 1. The amplitude in this situation is equal to 1, and that's the default, right? The default is this is going to be 1, and this is going to be 1 as well. Now, of course, we can transform it to make it so that it isn't 1. Now, what about the midline? That actually I probably should have talked about first, but the midline is by default just this x-axis, right? The x-axis is by default our midline, but our midline can go up or down. And this is the line where we start with on our sine function, right? And it's this line here on our cosine function that's halfway between the minimum and the maximum. So the midline is halfway between the min and the max. Okay, so it's halfway between our minimum and our maximum. Sorry, I'm going to write halfway a little bit neater there. But yeah, it's halfway between those two. Right? So that's what we need to know. We need to find our min point and our max point and take the average and find the midline that way if it's not obvious to us what the midline would be. But yeah, those are the three main components of our graph. Let's get back to the main part here today. So first, I'm going to draw this graph here. Y equals sine x, just as we did before. In fact, this is exactly the same as what we've done before. Oh, I drew that point in the wrong spot. Oops. All right, there we go. So basically, what are the different transformations? So A, what this does, if we remember A from back when we did just general transformations, A is something that determines, it determines, first of all, whether the points are inverted or not, right? If A is negative, then that means we flip, right? That means that we reflect in the x-axis if A is negative. If A is positive, we do nothing. Now, A also changes the vertical stretch, right? A gives a vertical stretch. And in this case, what will that do? That wouldn't change the midline, but that will change the other points, right? That will change our amplitude. So for example, normally A will be 1 in the default. However, if A is 2, that means our amplitude is 2. If A is 3, our amplitude is 3, and so on, right? So we're basically taking it and we're stretching it. We're taking those endpoints and we are stretching them to whatever extent A says. So A determines if it's inverted or not, but also A determines, what our amplitude is. So basically, one way to think of it is A is the amplitude, or I should really say absolute value of A is the amplitude, because the amplitude is always going to be a positive number. Negative with the A is just separate, right? That just says that we reflect in the x-axis. Now, what about C and D? So D and C are actually exactly the same as they were previously. So basically, D is the phase shift. So it tells us if we're going left or right and by how many. So if D is 3, for example, we're going right 3. Now, it will, one thing I want to mention though, is that it will look like -3, right? If D is 3, we already automatically have a minus sign in this equation. So when it looks like it's -3, D is actually a positive number, so we're actually going right. Or let's say this is plus 2. Well, since a negative was originally an equation, what that means is that D was -2, right? We have x minus and then D is -2. That's equal to x plus 2. So that actually means we're going left by 2. So it's actually the opposite of what we would think that it was. Okay, so do keep that in mind with the phase shift. And that's about left and right. Now plus C, this is how many steps we go up or down. So this affects the midline specifically, right? Midline by default is 0, right? We have plus 0 here, we don't have anything. However, we could go up, we could move the midline up or down, and therefore move the rest of the graph with the midline as well, up or down that many steps. C is exactly what we'd expect though. If it's plus 5, then we go up 5. If it's -3, we go down 3, and so on. So it's exactly what we would expect. So I'm hoping these transformations are really familiar for everybody, because the great thing about them is that they're very similar to transformations we've done other times, and that final exam is coming up. So reviewing all transformations will greatly help you. All right, so let's move on to example 2. It says state the following equations, graph the following equations using at least 5 points. State A, D, and C, and find the range of the transformation. Okay, well, let's see here. What are A, C, and D, first of all? Well, let's see. A is 3, right? A is the number in front of the sign, and it's 3. And then there's no D or C, so we can just say D would be equal to 0, and C would be equal to 0, because I don't see them there, so they're just 0. Now, A by default is 1. Keep that in mind, that if there's no A value, it's just 1. because 1 times sine x minus d plus c, right? Whereas with minus d and plus c, it's 0, right? X minus 0 is x, and plus c, right? To have that be nothing, it would be plus 0. So it's just a matter of the multiplication identity, which is 1, right? 1 times anything gives back itself, versus the addition identity, right? Where 0 plus anything gives back, or anything plus 0 gives back itself, right? Okay, so now that we have that, it says to do what? It says to graph using at least 5 points. So here I'm going to graph this, and this A changes my amplitude. So instead of amplitude 1, I'm going to do amplitude 3. So it's going to be exactly the same as this other graph I drew. The only difference is I'm going to make my amplitude 3. So as you can see, this graph has been stretched, right? I made my amplitude 3 in this situation. Now they also ask, what is the range of the graph? Well, the range is going to be from -3 to 3, right? Normally it would be from -1 to +1, including those terms. In this case, we've expanded that range all the way from -3 to +3 because we changed our amplitude. So that's why it switches there, right? Because the range of this first one here, is going to be from -1 to 1. Now, it doesn't ask for domain because the domain of all sine and cosine functions, assuming they haven't been altered, just regular old sine and cosine functions, it's always everything, right? Domain is always every single thing for all of these. And so asking for the domain, your teacher could do that. We could do that, but that would be kind of futile because it's always the same anyway. It's always just everything's included. Whereas the range changes with the amplitude and also with the midline, right? If the midline goes up, then our range is changing, or if our midline goes down, our range is changing, and then also the amplitude changes it as well. So 2 out of those 3 things we talked about do actually impact the range. So the range can change depending on our transformations. Whereas there's no transformation that we could do that would, that would actually change the domain. That just wouldn't happen. All right, let's do this one here next. This one is sine x plus 45. Now notice the plus 45, it's within the bracket. So that tells me that has something to do with D, not C, right? Because C is outside the brackets, D is inside the brackets. So this must have to do with D. D must be negative 45 degrees. Now, why did I say negative 45 and not positive 45? Well, because there's already a negative sign here, right? So if we already have a negative sign, to get a positive sign, we need another negative sign. So we need negative 45 to be D in order to get overall a plus 45 degrees. So that's why I'm saying that D must be negative 45. Now, what about A and C? A is 1, right? 1 times all this stuff. And then C is 0, right? Because for D and C, again, 0 is our default. And for A, 1 is our default for reasons explained earlier. Okay, now let's draw this graph. So this graph says we are going to go left 45 degrees. So I'm going to draw the same graph as the first one, but I'm going to go left 45 degrees. So I'm actually going to start here and go like this, and then down here, not quite, sorry, here, and then down here, and then back up here. So again, same pattern. It's exactly the same as the one before, except that I just moved it to the left by 45 degrees because that's what the transformation asked me to do. In terms of the range for this one, we actually didn't change the midline, nor did we change the amplitude. So the range of this transformation is actually the same as the range of the original. So I'm just going to copy down that range, and then we are good to go, right? But notice that the highest point, the maximum is -1, or sorry, the maximum is +1, the minimum is -1, and therefore it's going to be the same. Oh, I guess I drew it a little bit off here. I drew it more as -1.5. It should be -1. But there we go. All right, let's move on to, looks like we have 4 more examples before the homework. So let's do these 4 more examples, and I will leave the rest to you guys for homework. All right, so for this one, looks like we have A is just 1. Looks like C, which one is C? C is that one, and then D is the one inside our brackets. So in this case, D is 45. Now this time D is positive 45, right? Because the negative is already part of the equation. D is just the 45 part. And then C is going to be 1. So what does this mean? This means that we are going to move up. We're going to move our midline up to 1, right? Our midline before was at 0. Now our midline is going to be 1. So I'm just going to make kind of a dashed line there to show our midline is 1. That's our starting point. That's our new x-axis, so to speak, right? And then we have that D is 45 degrees, so we're going to be moving this time right by 45 degrees. Even though it says -45, again, it's positive. We're going to go, we are going to be moving right 45 degrees. So normally we would start here, right? But this time we're going to start here, right? We're moving right 45 degrees, so I'm going to start there. And normally we would start on that x-axis, but in this case I'm not going to. I'm going to start on my new midline, right? We changed the midline from the x-axis to 1 above. And now that I have that as my starting point, I'm going to draw everything else as I normally would. So let's draw that, and there, and there. And then we can draw another one on this side, I suppose. And there. And then there. Mm-hmm. Oh, and this one, sorry, should actually be here. So there it is. So one cycle of this, I want to be clear, it's just this part, right? This other part I just drew because that was where, the graph was. Let's put some arrows on that to show that it does go forever. And what was the other question? The other question was about the range. So the range here is from the minimum to the maximum. So the minimum here is 0, right? The minimum is on our x-axis. And then our maximum is up at 2, right? That's as high as this goes. It goes up to 2. So therefore, my range would go from 0 up to 2. All right. Next, let's try this one here. This one we have A is -1. C is nothing, right? So C is 0, and D is 2. Okay, so let's put that in. Then what does this mean? It means our midline is going to go up by 2, and that our amplitude is still going to be 1. However, we're going to flip our signs, right? So we're going to reflect through the axis. And keep in mind, we reflect through the axis before we move up with the midline, and so the reflection will really look like it's across the midline as opposed to the x-axis, even though it originally was through that x-axis. Good. So let's try that. And there's no phase shift, which is nice. Phase shift is not really a lot of people's favorite thing to do, so it's nice that we don't have to do that. So this time I'm drawing it kind of backward or opposite, so to speak, because we are reflecting. And I'm also drawing it up by 2, right? Because our midline has switched here, right? Let's draw some arrows. And there we go. Very good. All right, and we have 2 more left. Let's try E. Okay, so this time we actually have 3 non-default things, which is going to be interesting this time. We have that A is 2. We have that D is 90. And we have that C is -1. So this time, our midline is going to be at -1. And we're going to move over to the right by 90 degrees. So rather than starting here, we're going to start here. And our amplitude is 2. So we're going to go up 2 from -1 to get to +1, and also down 2 to get to -3. So let's do it. Let's do it. Okay, so let's go up to there, down to there, to there, and down to there. And you might notice, oh, hey, isn't this cosine? And yes, it is. It is, right? Because all cosine really is the sine function and then just shifted 90 degrees. And here, this is a sine function where we shifted 90 degrees. And therefore, this does look like a version of the cosine function that we wouldn't need a phase shift for, which is pretty interesting. But yeah, there it is. That is, I realize it says sine, but this, yes, this is indeed the correct graph because cosine and sine are the same graph. One just shifted. All right, let's do one more example, and then I'll leave you guys with some homework for today. Okay, so let's try this one. Here we have that A is -2.5, so that means two things. It means our amplitude is 2.5, and it also means that we are going to reflect in the x-axis. Then we have D is equal to 45 degrees. That means we're shifting 45 degrees to the right. And then we also know that C is equal to 1. And what does that mean? That means that our midline is going to be at 1 rather than 0. So let's draw this. Well, first of all, I'm going to be starting my graph over here at 45 degrees because we're going 45 degrees to the right. And then I'm going to have everything reflected. So we're going to start by going down rather than starting by going up. And we are going to draw our next one down here, 2.5 less than 1, which is going to be negative 1.5. So here, and then back up to there. And then 2.5 plus 1 is going to give us 3.5. Yeah, 3.5. So actually that goes a bit above the graph, but that is okay. Let's say 3.5 is right about there, and so on. So let's draw what we have of our graph. Let's draw that a little more accurately because I want to make this look like it is the top point, right? Because we're going to go down after. Amazing. And then up there. And there we go. And this one, to some people, this might also represent, to some people, more, look like more like a cosine graph. And again, it is, even though we didn't actually go over by 90, we still shifted. And so this, this looks kind of halfway between a sine graph and a cosine graph, right? We did do some shifts, but not quite the full shift. So depending on which way you look at it, which way you think is the, which point you choose to be your starting point, this could look to you like either a sine graph or a cosine graph, because again, same thing, just phase shift difference. But there you go. All right, well, that is everything for today. I do have some homework available, so I do have some of these questions as well for you guys to try. And you can also check your answers using a graphing calculator using Wolfram Alpha. That is the nice thing, that when you're practicing with these, it is fairly easy to check your answers if you're not sure exactly, exactly what the graph is supposed to look like, that sort of thing. And yeah, that's pretty much that. Next time, we'll be talking about sinusoidal models. So, yeah, we will see you then for that. Bye, everyone.